All right, this is Mr. Gillum, and today we're going to talk about scale drawings and models. So things like maps or like toy cars or like model bridges or whatever it is that we're talking about. Replicas, kind of, except for smaller. So when I'm talking today, when I say scale model or scale drawing, I'm talking about the miniature version of what we're trying to represent in a bigger form. Okay, the scale is a comparison of the model to the actual length being modeled. So again, it's still the image to the pre-image, or in this case we would say the model to the original. Okay, so it's still image to pre-image in our comparison. And today, because our models, when we talk about models or scale models, we're usually talking about a smaller version of a bigger thing. Our scale factor should be below 0, or not below 0, below 1, and greater than 0 for all of these. So let's take a look here. Scale models. So I snagged this example out of the book, and it says the scale on the map shown is 0.4 inch to 40 miles. Find the actual distance from Nashville to Memphis. So what we're going to have to do is we're going to have to use your ruler. And so I'm going to approximate this, and we're going to say that it's about 1.5 inches from Nashville to Memphis. So we're talking about this from here to here, obviously on the board and that I'm doing it on, it's more than 1.5 inches, but in the book, if we were to measure it and we had it on our paper, maybe on your piece of paper, it's closer to 1.5 inches, that would be fine. Okay, so it already has a scale for us, and like I said, the units are not significant. Scale factor, it doesn't matter with the units. Okay, so in this case, we got 0.4 to 40 equals, in this case, what we have in front of us, we know exactly 1.5 inches in between the two cities. So we'll keep the units the same as far as where they go on the second ratio. 1.5 is to x. We don't really know how far it actually is. So we're just setting up proportions again today. So it's very similar to what we've done. And then I just solve my proportion. So in this case, 0.4x equals 60 and divide by 0.4. So x equals 600 divided by 4, 150. 150 miles. Okay, we're comparing inches to miles. So it'd be 150 miles. Okay, so pretty straightforward, and then we're just using these proportions, these similarities to actual applications like maps, or in the next example we're going to compare in like a toy car, okay, model car. This is important. I've kind of said this several times throughout, but I just wanted to put it in writing for you so you can reference it. The scale factor of a drawing or scale model is written as a unitless ratio, okay, in simplest form. Scale factors are always written so that the model length in the ratio comes first. Okay, so this is just reinforcing that we're talking about image compared to pre-image. Okay, so this is a miniature replica of a 1923 checker cab. The length of the model is 6.5 inches. Okay, and it says the actual length of the car was 13 feet. What is the scale of the model? So the actual length was 13 feet. So in this case, we have the comparison 6.5 to 13. Because it's just asking about what the scale is, we can just say that in this case, if I wanted to reduce this 6.5 and 13, 6.5 is exactly half of 13, or 65 is exactly half of 130. We could say that the scale model is 1/2. And like I said, we use K as the variable to represent the scale model. And so that would make sense because the model should be a compression or a compression of a reduction of the actual car. So in this case, for part A, it just says what's the scale. I'm going to say it's 1/2. All right. How many times as long as the actual car is the model? Now, using that same ratio that we were just talking about, let's make sure I get it right down, the 1 to 2. we're talking about 1 inch for every 2 feet in this case. That is what the problem says, okay? We're saying inch and then feet. So these are inches on top and feet on the bottom. My scale factor it doesn't matter what the units are. However, if it asks me something like how many times as long is the actual car model, I would have to change my units a little bit. So in this case, I want to know actually inches compared to inches. So, or feet compared to feet. So I would say that really this is 1 inch compared to 24 inches. So the car length is actually 1/24. The model car is actually 1/24 of model is 1/24 of actual car. Okay, so the scale factor is 1 to 2. That's fine, but if we're actually figuring out for certain how big the model is compared to the actual original, we would need to have common units to make that comparison. Okay, that's it for today. Pretty straightforward, and then we got a test coming up.